Bismillahirrahmanirrahim. Today we discuss electromagnetic waves. Electromagnetic waves are the radiations in which electric and magnetic field are both oscillating at perpendicular to each other and in a wave produce also perpendicular to these two fields, electric as well magnetic field. Electromagnetic radiations waves जो है are of low frequency such as ultraviolet rays, visible spectrum, infrared rays, and while the high frequency and high energy radiations such as X-rays, gamma rays, these rays has dual nature, particle nature as well as wave natures. Electromagnetic radiations are explained by two types of theory. There are two types of theory: a wave theory of electromagnetic radiation, which was given by Maxwell. Wave theory of electromagnetic radiation given by Maxwell, and second theory which explains the electromagnetic radiation is quantum theory about electromagnetic radiation. First, we study the wave theory of electromagnetic radiation. Dear student, you know that Maxwell found that electromagnetic radiation is made up of two mutually perpendicular, simultaneously oscillating electric and magnetic field, as shown in the diagrams. You know that in initial stage, the string wave that is with a high amplitude and a greater distance between the two crust and trough. It has low energy, low frequency, and high you have wave numbers. Low wave numbers, while it's have the very you have low wavelength. In which these high जो string there is a the waves are fall are radio waves, microwaves, and infrared waves. And student, you know that visible spectrum is from the 400 nanometer to 750 nanometer, then ultraviolet that is below 400 nanometer, then high energy and high frequency with low wavelength, X-rays and gamma rays region जो है वो of the string fall. This string जो है वो can be explained and other ways. In initial stages there are of the uh, high wavelength and other energy is very low, frequency is very low, and wave number is very low. While on in case of X-rays and gamma rays towards high energy, they have very high energy, high wavelength, high frequency, but very low wavelength. As we explained this in case of electromagnetic radiations, as shown in the diagram, electromagnetic radiation is made up of two mutually perpendicular fields in a plane at right angle to each other, as a sine of wave as shown below, in which electric field represented by A while magnetic field by the B. These are at right angle, and the wave also perpendicular to these two fields. The electromagnetic radiation is shown by the symbol OYZ. OYZ combinedly form the electromagnetic radiations. This is the all about the Maxwell wave theory about the electromagnetic radiations. Dear student, now we have discussed the quantum theory of electromagnetic radiation, the wave theory of the electromagnetic radiations. Maxwell wave theory failed to explain the various phenomena like photoelectric effect, Compton effect, black body radiations, uncertainty principle, Heisenberg uncertainty principle, and various types of spectra of various types of atomic spectra and their interaction with other matters or waves. Hence, quantum theory describe the electromagnetic radiations are consisting of the streams of energy packets called photons or quanta. Student, again listen. The quantum theory describe the electromagnetic radiations are consisting of the stream of the energy packet called photons in case of light, and generally they are known as quanta. They travel in the direction of the propagation of a beam with the velocity of light. These quanta or photon travel in the direction of propagation of a beam with the velocity of light. Mathematically, you can express energy is directly proportional to frequency of the radiation, and energy is equal to h mu. H is the Max Planck constant. While when we place the value of the frequency, that is equal to c over lambda, then equation become hc over lambda. If we place the value of the 1 over lambda, that is equal to reciprocal of the wavelength is known as wave numbers and represented by the mu bar. The equation energy become equal to hc mu bar, where h is equal to 6.626 multiplied by 10 power minus 34 joules per second. It is known as Max Planck constant. This is all about the two types of theory that describe the electromagnetic radiations: Maxwell theory, Maxwell wave theory, and quantum theory of electromagnetic radiations. And dear student, we have today discussed the two theories: Maxwell theory about electromagnetic radiations and quantum theory of electromagnetic radiation. Thank you. Allah Hafiz.